Coming to Duo Tech Talks. My name is John Oberheide, co-founder and CTO at Duo. Thank you, Vikas. Thank you. Good to see everyone out. We had our first Duo Tech Talk last quarter in San Francisco, same place. Ryan Huber spoke about security automation at Slack, so I'm glad he didn't scare all of you away from the event, and you decided to come back. Diogo, I've hyped him up a lot. He's one of the smartest people I know, at least like twice as smart as Ryan, which is a big thing to say. Sorry, Ryan. I'll see you later this week. Duo Tech Talks is primarily technical talks, although given the my background and what Duo does, we tend to focus more on security talks. But we've got a great roster of past talks that are all recorded, thankfully, so you can check out our YouTube channel and go view some of our previous talks. Like if you just kind of scroll through the list, I don't want to brag, but the speakers are like better than you'll see at Black Hat or whatever other conferences that you like. So all free for you guys to check out. Before we get started, anybody have like local announcements, interesting job postings in the security space? Anything they want to say? Shout outs to their mom.
HackerOne's looking for security analysts to help with bug bounty triage.
HelloSign is looking for a security and compliance manager and a senior security engineer.
Anybody else?
Hi. My name's Justin Hall. I work as community manager here at DG717. We're very excited to host these guys and to host any of you who are working in these areas. We can host events like this if you want to have people sit down and talk to each other. If you like to work at a desk and you're alone right now or in a small group and you want to have a desk, we rent desks to people in a sort of, they call it co-working now. So we have that kind of space. So co-working or events, please think of us. We'd love to host you if you have something cool going on.
Excellent, thank you. And I'm putting Ambrosia in the back here on the spot. She's our VP of People. Congratulations, just got her visa to be in the United States. Round of applause, yeah.
8 months, 4 tries. That's all. I know a great lawyer if you guys need one. This is my first actual Duo Tech Talk. Just started the company 5 months ago, but really excited to be here with you guys. I think one of the great things, I have watched the videos, John was right, they're awesome, which is great shared learning with you guys, and gonna be around. I know a lot of you guys are hiring, we're hiring too. We've got about 100 people to hire in the next 6 months, so I'll be here showing my face with pizza if you guys wanna talk.
And in particular at Duo, we're looking for some security talent. So we're looking for a VP of technical ops, DevOps, as well as security leadership and individual contributors on application security and corporate security. So if you guys are interested, come talk to myself, talk to Doug, Ambrosia in the back, Ben, Jacob, anyone with a Duo shirt on except for Vikas in the front here, past intern. So with that, I'd like to introduce Diogo. I don't know when Diogo and I first met. Probably through Dino years back at RSA when you were still at Square. I've always been really impressed with every conversation I have with Diogo. He's a really fast talker, so he crams in like 1,000 pieces of knowledge per minute, and you can only write so fast and absorb all the great things he's saying. So hopefully he'll slow it down for us in this talk. No, it's gonna be rapid. But Diogo was at Square, now he's at Docker, doing amazing security things, really turned around I think the perception of container security over the past few years. So give him a warm welcome.
Appreciate it. Perfect. With that kind of intro, this presentation is going to disappoint for sure. Thank you so much for having me today. Thank you, John, and the rest of the Duo security team for inviting me. My name is Diogo. Today I'm going to talk about secure software distribution in an adversarial world. I would like you to note that John invited me to do this talk, and I didn't really know what the target audience was, so I targeted him as target audience, which means I had to translate my title to emojis. So John, I hope you appreciate my emoji translated title. It was 15 minutes of my life that I'm never going to get back. Perfect. So secure software distribution in an adversarial world. Software distribution, as we all know, if we're working in security, is a really hard and ubiquitous problem. Every single thing that we do nowadays depends on software distribution and updates for actual security. We all know that right now, you can't really run a WordPress blog out there on the internet that is a month old. I mean, technically you can, but you are about to get a massive redesign anytime soon, anytime now. And so the reality is that we're depending on security, and we're depending on software update for security. And as developers, we have to deal with more and more and more package managers instead of less package managers. Right now, our infrastructures are depending on external sources of content, on NPM, on package managers such as RPM and Debs, et cetera, et cetera. And the funny part is that these things are all being managed by thousands of developers that we don't know in infrastructures that are totally outside of our control. So one thing that I would like to note is that every single day, there seems to be a new package manager. The number of package managers that are out there right now seem to be a strictly monotonically increasing function instead of actually converging. And the problem is that none of these people that are doing package managers say, today I'm going to build the most secure package manager in existence. No, what they actually do is, today I'm going to build a package manager. And so we add one more problem. I really like this XKCD comic, and I think it really represents the current state of affair, which is the fact that every single developer is using and depending on tons of these infrastructures to have their software be secure. And if our developers that are developing our applications looked at this and said, this is insane. I'm going to choose a small subset of these package managers that are known to be secure, and I'm going to focus on using them, we'll be fine, or the problem wouldn't be as big. But unfortunately, and as this Stack Overflow question actually shows, that is actually not what is happening. If this is a real question on Stack Overflow and somebody thinks that this is a really good idea, it means that a lot of people don't get it, right? So the reality is that in the context of software distribution, when I talk to you about a secure package manager, this is what we actually want, right? We want an Imperial Walker. We want an armored vehicle that is actually capable of distributing content and moving it from one place to the other in a secure fashion. In this case, bonus points for the laser cannons and medium blasters, right? But the reality is that this is what we want. We want an armored vehicle to actually carry transport our data. Unfortunately, this is what we actually get. We want an Imperial Walker, but we get stormtroopers with walking sticks. For several reasons. One of the reasons is it's so easy to create a package manager that everybody does it and nobody focuses on security. So the first thing that I hear on a talk like this, when I talk about software distribution, somebody puts their arm up and says, isn't this a solved problem? Isn't HTTPS enough, right? Why can't I just get a Let's Encrypt certificate, they're free now, I've heard, and essentially host my data on some server and just download it? Okay, so what you do is you'd host something on a cloud or some CDN or some distribution server, and obviously in this case you're being a software publisher that wants to publish software for a final consumer, and curiously enough, this piece of software looks very much like a Docker container that is totally not intentional. And the user using HTTPS, assuming that connection is encrypted and verified, downloads the content, installs it, and we're good. The problem is obviously that now you have to trust the CDN, right? The CDN can alter the content free will. And any man-in-the-middle attack, any problems that happen with the actual HTTPS connection, now you're vulnerable and content can be injected and malicious adversary remotely controlled code can be injected into your installer. So this is obviously really bad. And then the second question that people ask me is, okay, I understand that is pretty trivial, but what about GPG? Isn't package signatures a solved problem? Why can't we just use GPG to solve this problem? Well, let me give you an example of why GPG is actually bad for this kind of solution. The reason is that people use GPG as if it is a framework, when in fact, it's just a message format. You apply a signature to your application, and then you verify the signature. This actually leaves you to attacks like a downgrade attack. So let's go through this. You're the same publisher, and now you want to publish a piece of software. But instead of just putting it and hosting it on your CDN, you're going to say, I'm going to be really security conscious. I'm going to have my GPG key distributed through all my consumers. I'm going to sign it. So the green stamp that you see is the signature on the actual package. And then what do? You upload it somewhere to the CDN, and then obviously the user can download and verify the GPG signature. And so at this point, you're saying, okay, I get it. That seems fine. What are you going to do about it? How can you break this system? The reality is that you have to consider how the world actually works. 3 months later, after you sign this package and the user installed it, this happens. There's a vulnerability in the package. Imagine that Heartbleed just came out, or better yet, Shell Shock, right? Remote code execution as a service in all of your applications. Great, all of my applications are vulnerable. So let's patch it. What do we do to patch? We would patch it, re-sign this application, send it back to the cloud. At this point, you're thinking, why don't we repeat the final step again? Just download this package, verify the signature, and everything will be fine. Well, the problem is you applied a GPG signature directly to a package. So if something like this happens, and there's a man in the middle or control over the actual cloud, the malicious attacker can serve you the old version of the content. And remember, this is not just some old version. This is shell shock vulnerable old version, which is as good as it gets for an attacker. They're serving you something with a known vulnerability for which they have a known exploit. And you verify the GPG signature, but it's valid because you signed it. So at this point, I showed you a downgrade attack that is completely critical and essentially can have any TLS, man-in-the-middle attacker, or a privileged man-in-the-middle position compromise your infrastructure. The reality is that you have to think about software distribution as a framework, and the majority of package managers fail at this. Once you sign the key, how do you revoke the key? How do you actually give these keys out to your developers without giving them the private key material? How do you actually revoke packages? How do you deal with the freshness of the content? How do you deal with attacks such as downgrade attacks, mix and match attacks? There are tons of issues that if you start thinking about, you're vulnerable to by just applying a GPG signature. And this is going to be a theme throughout the whole presentation. And if you don't believe me, you should believe our friends here at Duo that actually have a really cool analysis of OEM updaters. And they essentially went through a list of OEM updaters, and then the quote that I took out of the blog post is, spoiler alert, we broke all of them. So every single OEM updater is broken. And I can guarantee you that every single package manager is broken. And I know this because there's public research or published research that shows a lot of vulnerabilities around package managers. Why? Because they apply direct signatures, they apply direct GPG. Sometimes they don't even validate HTTPS. So I'm not saying that HTTPS is bad and GPG is bad. I'm saying that the lack of looking at the problem as a framework in a holistic view is actually making us vulnerable day in, day out. There's this quote that I really like that says, a software update system is secure if it can be sure that the latest version is available, it updates in a timely manner, and every file it downloads are the correct files and do no harm to the system. This is a really high bar, and this should be absolutely what we try to strive for. So instead of looking at the old models and try to just use HTTPS and apply GPG, let's look at what do we actually want from a software distribution system. There's a set of characteristics that are really, really awesome for us to have. First one is freshness. Second one is signed collections. And then we have key hierarchy, transparent key rotation, and threshold signing. I'm going to go over one by one why we need them and what do they mean. So the first one is freshness. And I go back to the GPG attack, right? The reason why the attacker was able to serve vulnerable content is because there was no freshness guarantee. You applied the GPG key as a signature key, and now you're tying the expiration of the software to the expiration of the key. As long as that key is valid, your software is valid. If the key is valid for 10 years, your software is valid for 10 years. And software that exists for 10 years, it is not software that you should be installing, right? So this is the first problem. You're tying your expiration to your key, and you shouldn't. So freshness actually allows you to, if you have guarantees around freshness, it allows you to do cool things like you can invalidate content that is already out there. So in the case where you have mirrors that maybe didn't get updated and you have a new version of the content, freshness also allows you to essentially invalidate that content and make sure that all the updates and all the mirrors are either serving up-to-date content or there's a cryptographic failure when an updater tries to download content that is old. So that's our freshness guarantee. The second interesting thing that we have to think for a software updater is something called signed collections. So it turns out that software has versions, right? And versions have dependency on other versions. So for the longest time, we've been looking at this RPM package and saying this RPM package, Nginx, it is okay, my team has looked at it, it has no backdoors, so I sign it and now you can install it. Without thinking that this Nginx depends on tons of other things. And that there might be relationships of dependencies that make your software actually vulnerable or denial of service not work. So looking at packages as individual packages and not as collections of software that work together is a problem. Because I, as an attacker, can serve you, do a mix and match attack, choose what signed version I want to serve you, even if it's an old one, and essentially have the whole thing not work. So signed collections versus signed packages. Another one that is incredibly important is key hierarchy. You do not want to have this all masterful GPG key that controls everything and that has no expiration, right? What you actually want is you want to have one key that is very important and then multiple keys that you can delegate down responsibility to. Why? Well, because if you have multiple keys, it means that you can segregate where these keys are available. And you can have your root key be offline, for example, securely, and you can have a key that is not as important be delegated to your developer key or to your developer system or your CI system, where it's obviously naturally more exposed. So you can do, if you have a key hierarchy, something like this. You'd have a key with a very short expiry that lives on your cloud and therefore is more vulnerable. Then you have a key with a longer expiration time that lives on your developers' laptops. That could be the key that your developers sign with. And then finally, you have your key that is actually the root of trust of the system, which is your root key and should always be offline or live in a hardware module, hardware security module, what have you, right? So this is really important. Another important guarantee is transparent key rotation. Turns out that sometimes developers put their private keys on GitHub, right? I bet, let's be honest, it happened to every single person in this room. It's obviously never happened to me. But if you do put your key on GitHub, you have to rotate it, right? So now imagine the GPG case again. Imagine the GPG case just is on Diogo Monica, github.com/Diogo Monica. What do you do? How do you rotate trust? If your root key was the source of trust, how do you relay this? How do you go to every single system and replace this key? This is a huge problem. If you have transparent key rotation, you can do the following. In this image, I have the user that essentially has two keys configured. It has an online key and an offline key. And the online key was actually signed by the offline key and transmitted through all of our users. So when I put it on GitHub, and an attacker now has access to this key that is displayed in red, it got compromised. The only thing that we need to do if we have a capability of doing transparent key rotation is we bring the root key offline, we sign a new key, and then send it over to the user. And now the user just replaces this key because the root of trust was the offline root key, was not the key that was compromised. Think about this for a minute. This means that you have the ability of rotating the key that signs your software whenever you want. We're not talking about just when it got compromised. What if I don't know when it got compromised? Well, rotate it every week. Heck, rotate it every day, every hour if you want. It is transparent. The user doesn't see anything. As long as the root of trust is the key that is offline and did not get compromised, you get to continue doing this for as long as you want. So transparent key rotation not only allows you to essentially have a catastrophic failure, like the loss of a GPG key, turn into a completely normal process of renewal, you can actually mitigate against the known attacks by rotating your CI key every month if you want to. So that's really important. And the final one that I want to talk about is threshold signing. Imagine now that instead of one GPG key, you have the capability of mandating that multiple keys have to sign this package. Imagine that your process is, I have to have this package signed by my CI system, built and signed, and the security team has to put their stamp, right? You need a system that actually allows you to have the clients verify multiple keys simultaneously to make sure that when a user downloads it and it wants to verify it, it sees, oh, it did get signed by CI and it did get signed by security, and therefore I can run it. And the compromise of one key does not mean arbitrary execution of software in all of your clients, right? And so you can have pipelines of these things. You could have two, but you could have as many as you want. You can stamp the hell out of that signature or of that content and just add as many signatures as you want. And even though this protects against real attacks and infrastructure attacks, it also protects against what we call the subpoena attack, where if you can be coerced by a nation state to actually sign software and distribute software to all of your devices, maybe what you want to do is you want to host multiple keys in different countries. I don't know, randomly out of the top of my head, Russia, China, and the United States. And if you require 3 signed keys for your update of I don't know what to actually be installed on your phone, means that your company, if it's only in the United States, cannot be coerced to send malicious software without the team from Russia and the team from China agreeing with it. So this is a really important characteristic. And obviously, you can extrapolate this for tons of security issues that you have internally, and you can have just quorum systems that apply their signature. But it's really important for you to think about it. It's our job as security engineers to make sure that we're as resistant as possible to attacks like subpoena attacks, not just technical attacks. So now you're wondering, okay, you described all of these characteristics, and some of these seem easy, some of these seem really complex. Has this been done before? Can I follow something? Can I just install a software, or can I just follow a guideline of how to do this? Well, the answer is yes. There is something called TUF, the update framework. TUF is essentially something that came after the people and the great developers from Tor decided that they needed a state nation attacker resistant method of update. So they started researching how they should do it, and they started looking at the exact same guarantees I just went over with you, and they said, okay, let's design a system that can resist against all of these problems. And so a group of researchers looked at that work and essentially made it better, or made a paper out of it, and then analyzed the security characteristics and turned it into a framework called TUF. So by using TUF, the updateframework.com, you're essentially getting a system that has already been field tested by the people that run at Tor. The attacks that it considers are a lot more than just key compromise or mix and match. I have a few examples of attacks that are here, but problems that we don't really think about on our day-to-day setting, but are actually incredibly important. For example, look at endless data. It turns out that if you don't know the size of what the package should be, an attacker can do attacks like serve you infinite data. Continue serving data. Your system believes that it's successful downloading and updating the system. No flags are raised, but you're not getting an update. Or actually being incredibly slow at serving you the data to delay your update as the maximum possible. So attacks like this that we're not considering, we're always thinking binary, remote code execution, or bust. No, there's a lot in between, right? So this framework tries to consider as many attacks as possible. And the way that it works and the way that it provides these guarantees, and let's go to some of the guarantees I described before, is it has a key hierarchy. Surprise, surprise. I told you that it was useful. They use one. Their key hierarchy has 4 main keys. The root key, which is the anchor of the system, and therefore has a little anchor on it. Cute. The targets key that actually is used to sign the actual files that you download. The snapshots key that is used to give us the property of collections versus signed packages. And then the timestamp, which is used to give us the freshness guarantee. And it also has delegations keys that allow you to essentially not have the targets key be the only key that you need to provide. You can say, no, my CI team can only sign CI things, and my security team can only sign security things, and my cloud team can only sign cloud things. So delegations allow you to delegate responsibility for other keys. So as I mentioned, root anchors trust, target signs the target metadata, which are the files, snapshot collections, and timestamp frequently resigns the snapshot to make sure that it's up to date, and we can detect attacks that are around freshness. In delegations, in TUF is about paths, so you actually delegate down paths. You can say somebody owns this path with this key, and then only that private key can actually sign for that particular path. That's how they implement delegations. And they also implement thresholds, so you could have the guarantee that I told you around the subpoena attack and the capability of having multiple keys sign it, and they do it by actually requiring a number of threshold for a specific role. If the role security needs a threshold of 2, then therefore I need 2 keys from the security group to sign this. In terms of freshness, how do they actually guarantee freshness? Well, in TUF, the 4 files, or the 4 keys, actually also correspond to 4 different files. They're JSON files, and you can think of them as the actual metadata that makes the whole system work. And these files have expiration, all 4 of them. The root file has expiration, the timestamps has expiration, the snapshots has expiration, the targets has expiration. The way that the freshness is guaranteed is we require that the timestamps file is signed with a timestamp key in a duration of 2 weeks, which means that if an attacker wants to do a freeze attack and pretend to your system that everything is cool, but that there are no new updates, it can only do this up to a week, or up to 2 weeks, or up to 3 weeks, whatever you configure. So that's how we protect against freshness in TUF. And this allows you to have early detection of untrustworthy data. Obviously, this means that the root file has a longer expiration. We're going to see that later. And that comes down all the way to timestamps with shorter expiration. But every single file of the system has this characteristic. In terms of signed collections, the way that TUF guarantees that this is a whole collection of things and not some individual files, the way that they do this is they essentially have a Merkle DAG of the files pointing at each other. So I mentioned 4 different files, and as promised, we have 4 different files. We have the timestamp file, snapshots file, the root file, and targets file. The thing to notice here, though, is that the timestamp file actually includes a hash of the snapshot file. And the snapshot file includes hashes of both the root files and the targets file. So by just having the snapshot file, you have a snapshot of what the collection is. And by having the timestamp file, you have the current available snapshot. And so this Merkle DAG of hashes pointing to other files that you can actually verify gives us this characteristic of collections. Because we can mint a collection, and from that moment on, this is the collection that is signed and that we're working with. So for you to get a little bit of an idea of how this actually works in practice and how day-to-day operation of TUF actually follows, I have a short diagram to take us over this. So day 1, I init a new dupdate framework repository. I have a TUF repository, and it has the 4 files that I mentioned. And as I mentioned, the root key is the most important key, has the longest expiration, and therefore the root file also has the longest expiration. So you have a root file with the longest expiration, you have the targets file with shorter, snapshot with shorter, and timestamp with very short, because again, provides freshness guarantees to ensure that we're not being frozen in time. So when situation is normal, essentially every time the timestamp file expires, we just sign a new snapshot. In the case the snapshot expires, we just use the snapshot key and we sign a new snapshot. And we continue signing timestamps for as long as there are no changes in the TUF repository. But now imagine that I want to publish something. Remember, targets key is the thing that we actually use to sign new contents. So what are we going to do? Well, we're essentially going to we have new things to publish, so we create a new file that is a targets file that points to our new things that we want to sign. We sign it with the targets key, and then we sign the new snapshots with the snapshots key, and then we sign the new timestamps with the timestamp key. Okay? So now this is situation normal. We've seen how timestamps get reissued, we've seen how normal files get reissued, and we've seen how we actually update targets and add new things to the system. But what about when a targets key gets compromised? This is that guarantee around transparent key rotation that I mentioned. How does the system actually handle it? Well, remember, the root is the actual anchor of the system, right? That blue anchor is what we're actually trusting. The blue anchor actually tells us that the targets key has a certain ID, but we don't explicitly trust the targets key. We implicitly trust it through the root key. So if the targets key got compromised, the only thing that we need to do is we bring the root key offline, we sign a new root key file with the root key, and then we sign the targets file with the new targets key. We sign the snapshot file with the old snapshots key, and we sign the new timestamp with the old timestamp key. I mean, heck, we could have rotated all 3 of them because it's completely irrelevant. The moment you sign the new root file, the root file describes what keys are trusted in the system. And therefore, you have a whole new set, potentially, of keys that you know to trust because you trusted the root in the first place. Okay? And now the obvious question is, cool, but what about the root key? It's what you are all thinking. You don't need to say no because there was a bunch of people smiling, so I know you were thinking about the root key. Well, the reality is that the root key can also be rotated with a caveat. Well, in the first place, if it got rotated, got compromised right there, the first thing that we would do is we would create a new root file, we would sign it with the old root key, and we would essentially rotate our root key out of existence. So we essentially have the repo being initted, signed by the old root key, but with the new root key as a trust. But note that if an attacker compromises the root key, and the attacker has the ability of distributing the TUF metadata throughout all of your users, then now you're essentially racing to see who updates it first. So there might be some users that update the attacker's key first. There might be some users that update yours first. But the reality is that this mandates that your root key was not just leaked on GitHub, right? That would be catastrophic before for the GPG case. In this case, you can actually recover from a GPG leak. The only thing that you need to guarantee is that you rotate it as fast as possible so that an attacker is essentially coming to the game very late when he actually gets the key. And if he does not have access to the actual systems and you're using TLS, then you have extra guarantees that an attacker can't just come along and very easily rotate your users out of your root key. So as you can see, the system resists both root key compromises and any other key compromise. Allows you to have transparent key rotation, has freshness guarantees, and all this key hierarchy that we talked about before. And so as a framework, this is cool. But what you actually want as implementers is understand how the framework works, but actually use something. I don't want to rebuild this. I don't want to have to implement this, especially because let me tell you, like those signing and like the keys and especially delegations is a really pain to implement. So what you want is a tool. And so at Docker, we actually created a tool that does this, that implements the update framework. We call it Notary. We thought it was funny because notaries actually stamp things. I learned after I came to the US. We have other words for notaries in Portugal. And essentially, Notary allows you to create a tough server that we created and have trust over files, using delegations, using thresholds, using key rotation, allows you to manage your keys. What that actually looks like in reality is something like this. Notary allows you to securely map names, like latest or 1.9 or whatever version of your software, to secure hashes. If you think about it, if you have a secure hash of content, it's all you actually need. And so what that actually looks like is if you do a Notary list, Notary, by the way, is a CLI tool too. It is essentially something that it's a framework that you can integrate into your application, but also comes with a CLI. If I do a Notary list of a bunch of keys, you're going to see three things. Number one, you're going to see the name that I promised you'd see. In this case, Edge, latest. These are Docker containers. So this is our naming scheme. It could be really anything. You see the secure digest, SHA-256 of the actual content. And then you see the size in bytes of the piece of data that you're actually downloading. Why? Because again, you don't want to be in infinite data attack. And therefore, you know exactly how many bytes you're supposed to receive when an update, in this case, when a container is being pulled. And then obviously you have the role. In this case, it was the targets key that actually signed this name. And as I mentioned, Notary is not just a CLI tool. It's actually a framework that you can integrate. And so it's very easy for you to essentially do this exact thing in your own code and essentially just bootstrap a repository and then do a listing operation on it. It is so easy, in fact, that even us implemented it into Docker. Obviously, we built this in a way that is independent, and Notary is a completely independent project, even though it lives under the Docker GitHub repository. But as a first implementation, we decided, let's prove it ourselves, eat our own dog food, and put it into Docker. And so if you're familiar with Docker, Docker has a pull concept, right? When you do Docker pull with Alpine latest, what you're actually saying is, I want to download the container image Alpine with the tag latest. And then that data comes from remote. So a thing that people don't know, or the majority of people don't know, is that in the background, Docker is actually a content addressable system. So if you look at this Docker pull closely, you're going to see that there's actually a digest right there, which is a SHA-256 of the content that is being pulled. So if we had this hash, we could actually be 100% secure. If we had a trusted source of this hash, somebody that told us what this hash is supposed to be, you could just download the content and verify the hash. And you're sure that the content that you're receiving is the right one, right? But now you have a naming problem, which is you're pulling Alpine latest. You're not pulling some random hash. But Docker provides you the ability of pulling a random hash, which is what I'm displaying here. I could have done exactly the same pull instead of Docker latest, Docker Alpine, and then pass it to SHA. So this is where Notary comes in, right? Notary allows you to have this translation between names and hashes. And if you have a content addressable system like we do with Docker, in a content addressable system, essentially in summary, is a system where if I ask the remote system for a hash, ABC, the content that I receive when hashed is ABC. So I already have the identifier for the content, I just don't have the content. But I can verify that the right content is being given because I know what the cryptographic hash of it is. So now we have essentially the perfect mapping. We wanted a hash from a name, and Notary provides us a hash from a name using the update framework. And this works really well for Docker because Docker pulls are actually turtles all the way down. And what I mean by turtles all the way down is Docker manifests actually are a Merkle-directed cyclic graph. So in a manifest, when you do Docker pull, you're not receiving data. You're receiving a manifest that then tells you all the other hashes of all the other manifests, that in turn tell you the hashes of the other manifests, that then in turn tell you the hashes of the actual layers. So it is essentially a chain. You always know the next hash that you're supposed to verify, which means that if you give me the correct SHA-256 hash of the manifest file, which Notary does for us, you are sure that you're getting the right content. And so this is what we did. We essentially use Notary, integrate it into Docker, and you can actually enable this kind of functionality into Docker. And you can have Docker sign all of your pushes with your keys and have all of these guarantees of the update system and of the update framework, transparent key rotation, freshness guarantees, etc., for your own repository or even using the Docker Hub. This is kind of cool because it means that the Docker Hub can be entrusted from your perspective. We are just essentially a dumb storage content mechanism. You have the keys. You are the only people that are able to sign new content and publish to Notary new hash mappings. And any user will verify and knows that Docker cannot create any content for you because it trusts your keys. So I really believe that it's time for us, security engineers, but also for software developers and system administrators to really start taking software distribution seriously. As we saw before in the Duo blog post, OEM updaters, all of these things that we're depending on day in, day out, NPM, Brew, whatever it is, they're all mostly broken. And this is our security of our applications. One package, one gem that is compromised, and that's essentially mostly game over. So I think it's time for us to start taking this seriously. And as one of my favorite coworkers usually says, when the going gets tough, you should absolutely get tough going. Thank you very much. And now we open for questions. Question in the back.
Hello.
There you go.
Great. So where are the public keys that are used to verify?
Where are the public keys that are used to verify? So in the system, when you first publish a repository, what you're actually doing is you're creating a random set of private keys locally, and then you're assigning all of the things, all of the chains, and hooking them together. And what you're publishing to Notary server is just public information. It's just a set of JSON files that are signed. And the JSON files include the public keys that you're trusting. So right now in Docker, if you don't do any kind of pinning, and we have the ability for you to do pinning to CAs or pinning to actual repositories, but if you don't do any kind of pinning, what is happening is on first Docker pull, it's trust on first use. So you go over HTTPS, so always over HTTPS, and then you download over HTTPS the first root.json file. Then from that moment on, you grab a hold to it, and you never let go. And that's the only thing that you're ever going to trust again. So it's searched on first use, you get the public keys, then from the moment on, everything works within Tough, and it has all the rotations and all the capabilities that we're describing. And you do have the ability of essentially pinning that, or in your own infrastructure, pre-distributing what the trusted mechanism is with Puppet or whatever it is, what have you, when you're setting it up, and it's essentially not depend on trust on first use. But the answer is public keys are inside of the actual JSON files. Question right there.
Now, you mentioned timestamps. Do you timestamp the time source?
Do I timestamp the time source? No. This is all essentially best effort faith on MTP servers. We ensure that all our MTP servers use HTTPS, but this is essentially the same issue that you're going to have with TLS, right? So we're all depending on time, and we're not actually depending on any kind of like sophisticated synchronization. If a user's laptop has the time that is way off, then it's going to be vulnerable to not verifying this.
Well, that's because I do CA, so that's one of the standard tricks.
Correct.
Forward time.
Same model as TLS. So time drifts on the clocks of the customers or the clients. If you try right now on your laptop to change your time clock to somewhere in the future, Chrome is going to give you some interesting experience. It's actually pretty fun to watch every website on the internet being read. Other questions?
So there's a tension between that you refer to between like key expiry, like short-lived keys, versus offline, longer-lived keys. Is that just an artifact of like people not using HSMs, or just the administrative overhead of pulling your Luna out of the closet, or like why can't we just have both easily accessible keys that are securely backed and securely stored?
That's a great question. I think the idea here is that Tough allows you to have a very complex mechanism of signing, and you can have developers sign it, you can have your CI system sign it, you can have your staging system sign it, and then you can have your production system say, I will only run content if got signed by staging, got signed by the CI system, and got signed by one of my developers. And the idea is that not all of these keys have the ability of being in hardware, right? And even though even the ones that have, the reality is that you might not need to, or you might be in a cloud that doesn't provide it, or it might be too expensive to integrate. What Tough does is it makes every key except a root key essentially dispensable. You can rotate them out of existence. You can rotate them every week if you want to. And so if you have this capability, then hardware security module on your CI system or hardware security module on your cloud provider doesn't really matter that much, because you're constantly refreshing it and you have the ability of doing key recovery or recovery to key compromised. And so we actually, Notary, funny enough, integrates with Yubico, so you can have your root key in hardware. Notary actually integrates it seamlessly, so you could have out of the box when you generate a key, generate it in hardware, and then it's cool because it has touch to sign, right? So you need an induction touch, so malware on your computer can't just really like touch physically the YubiKey. So every signature operation has to be an actual induction touch. So we went through that trouble of Notary from version 1 has PKCS 11 integration, integrates with YubiKey, because I think usability is also the answer to your question, which is if you don't have a system that allows you to do this kind of security with hardware, with key hierarchy, with freshness in an easy way, nobody's ever going to use it. And you saw the Docker pull example. It is really as easy as that. It is Docker pull and Docker push. That was our first integration of Notary, was you Docker push. If you don't have keys, it generates it for you, and then asks you for your passphrase, signs the content. From the moment on, always asks you for the same passphrase to sign the content. And on Docker pull, the first user receives, trust on first use. From the moment on, trusts this sophisticated protocol and this sophisticated framework to guarantee that all updates are done by you.
So branching off the user experience thing that you were just talking about, what's the user experience like when key verification fails? Because I'm thinking of all the tutorials that teach you how to add a repository to a Red Hat-based system tell you to like disable GPG verification, right? So like users are really bad at making decisions about security.
Correct.
So,
So are you talking about from enabling the security, or from users shooting themselves in the foot and going and disabling it?
that one, users shooting themselves in the foot. So they're already using the secure update mechanism, but then all of a sudden there's a man-in-the-middle attack, and the certificates don't match, or the GPG keys in this case.
I think the only answer that I have for you is following the research that has been coming out of Google on how we disincentivize users from actually clicking through the red warnings, right? Which is equivalent issue is I really want to go to this website, but this whole thing is red. What do I do now? These are the only two pieces of information that I have. And now it's how much do I want to go to this website that essentially tells me if I'm going to click through the warning or not. So in our case, the way that we do it is we obviously do hard fail when that happens. And we don't make it that easy for you to go and recover from it. And we do give you some information and some online resources, but it should be incredibly obvious that this is actually something that is not expected. I think the reality is that in browsers, it was so common, and it is so common for people to do self-signed certificates that there is this, people see it all the time. And since people see it all the time, they're used to being read and it being okay. They click through, the world doesn't end, so everything must be right. Or SSH acceptance of every single key that they've ever seen. Oh, it changed, doesn't matter, this happens all the time. I think what we're focusing on is, instead of focusing on anything fancy on the rejection part, we're focusing on making sure that the flow of, we optimize for the flow of the normal path. And the normal path should be the 99.999%, not the 95% as browsers, where you get to see the red warning so many times that you just essentially start ignoring it. That's my answer. It's a good question. Other questions?
So I had a question. With Tough, can I go from, I'm running a Docker container, I'm running some software image, in terms of like kind of full scope of software supply chain, could I potentially say that like this software image chains all the way down to individual developer commits, all the way through CI, packaging, everything else, and all of those commits were YK4 attested taps?
Technically, yes, you can do that. I don't think we've gone down to that level of depth, but you can add as many delegations as you want and as many guarantees around who signed it as you want. There will be a point where it becomes impractical, right? You have so many keys going around the system that you can't really push to production without having like 30 people sign. That's going to take the whole night, and then there's time zones involved. But the reality is, yes, the answer is you could do that. Right now, we're optimizing for flows where you have your CI system sign in any developer, or you have your CI system sign in your staging sign. So simpler mechanisms, but that are automated. So it's just, nobody can just come to a production system and run pull arbitrary code, or it can just go to the staging server and modify it, or go to the CI system and modify it, or go to the Amazon S3 bucket from which you're pulling your artifacts and modify these things. And even if they do, and even if they modify that by compromising the CI server, it didn't go through staging, so they can't quickly just go and have that just go through the chain and going to production. So we believe that that's the major first step, but absolutely the end goal is, as you said, having a verifiable chain from commit all the way to production servers running an attestation that is actually running in production servers. Why not?
It's kind of just end-to-end, like you don't trust any of the goo in the middle. You ensure that, I mean, you have to trust developer endpoint and trust your cloud infrastructure, but the sort of chain of custody is maintained throughout the rest of your build process.
Correct, but the funny part is that if you do have a system that enforces pull requests, look to me like 2 out of 3 people or whatever it is, then you would have to compromise several laptops to actually get the signatures necessary for that. So if you go one step above, you can actually see that the systems that we have built right now, just out of best practice, can very easily be adopted to be incredibly secure. And you have some companies that are doing similar things. I think Coinbase is actually a really good example of a company that is taking it really seriously and has systems that are similar to this. Any other questions about Notary, about Docker? No? Perfect.
Anything
Thank you very
about,
much. Wait, there's
one
another
last
one?
one.
Shoot.
I saw when I looked at Tough, there were some things about pip. Any future plans for Tough in terms of kind of mainstream package managers?
Actually, one of the people on our team went to PyCon and talked about the integration, talked about Notary. So we're incredibly available to spend some of our time helping people integrate. And we're trying to do it with pip because this particular member on the team, Yang, she really likes Python, even though we do everything in Go. It's day in and day out seeing her struggle with her true love, but having to develop in Go. It's kind of funny. So we're definitely trying to help them out to have this be something that is used in Python. And at Square, in a previous life, the team at Square was actually trying to do this for RubyGems. So I do see a path forward where this is not just something that is built into Docker, that actually other people use this. And we would love for that to be Notary, right? We would love for Notary to be the tool that people actually use to do Tough across any package managers. Perfect. Thank you so much.
Thank you, Dio.